Claude is no longer just a conversational interface, it is a reasoning layer that can sit inside products, workflows, and enterprise systems. For an AI solution architect, the first skill is not prompting, it is knowing how Claude behaves under real constraints, model capability, context size, token cost, latency, structured, output, and failure boundaries. Master this foundation, and every later architecture decision becomes sharper. The hardest part of building with frontier models is not calling an API. The bottleneck is designing a system that stays reliable. Users send messy input, long documents, ambiguous requests, and changing business rules. A weak architecture treats Claude like a magic text box. A strong architecture treats Claude like a production component with limits, contracts, and measurable trade offs. Claude design starts with model selection. Anthropic positions Opus 4.8 as the most capable Opus tier model. Sonnet 4.6 offers the best speed intelligence balance. Haiku 4.5 is the fastest model with near frontier intelligence. Workload shape determines architecture, not hype. Deep reasoning, balanced automation, or high volume speed. Claude API docs. Every model decision creates a cost latency intelligence triangle. Anthropic lists Claude Opus 4.8 at $5 million input tokens and 25 per million all output tokens. Sonnet 4.6 at $15 and Haiku 4.5 at $15. The lesson is brutal but useful. The best model is the cheapest model that still passes your quality bar. Claude API Docs 1. The context window is Claude's active working memory. Anthropic documents 1M token context windows for Claude Opus 4.8 and Sonnet 4.6. Haiku 4.5 has a 200K token context window. Large context changes what architects can build. Document reasoning, multi-step analysis, long agent sessions, workflows where state matters across turns. Claude API Docs 1. Tokens are not just billing units, they are memory, latency, throughput, and design pressure. Anthropic describes context usage as growing linearly across conversation. Turns, prior user and assistant messages are preserved. Architects must decide what stays raw, what gets summarized, what moves into retrieval, what should never enter the prompt at all. Claude API docs. The messages API becomes the control plane for Claude applications. The architect defines system instructions, user input conversation, state model choice, maximum output tools, and response contracts. This is where product behavior becomes explicit. A vague prompt creates fragile demos. A well-designed message contract creates repeatable software behavior that engineering teams can test, monitor, and improve. Real applications cannot depend on beautiful prose alone. They need predictable structures like JSON objects and fields. Validation rules and failure handling are also essential. Anthropic recommends structured outputs for valid JSON. Claude produces output that conforms to a schema. This changes Claude from an answer generator to a reasoning component. It becomes part of typed workflows, databases, and dashboards. See the Claude API docs for more information. Latency is not only a model property, it is an architecture outcome. You reduce it by choosing the right model tier, limiting unnecessary context, caching repeated prompt prefixes, streaming useful output, separating real-time requests from batch workloads. Anthropic's prompt caching is designed to reduce processing time and cost for repetitive prompts, especially large contexts and consistent instructions. Claude API docs. The foundation is a simple operating model. Classify the workload, choose the model budget, the context, define the message contract, enforce structured output, measure cost and latency, then iterate with evaluation. This is the shift from using Claude to architecting with Claude. Week 1 is successful when every AI feature becomes a deliberate system decision. not an experiment hidden inside a prompt